Hello, my name is Gabe. For this problem, we're asked to find the values a, b, and c such that this is the graph of f of x equals a sine of bx minus c. Let's begin by finding the amplitude a. Let's recall that the amplitude is 1/2 the distance from the maximum values to the minimum values. And here, the maximum values happen when y is equal to 2, and the minimum values happen when y is equal to -2. So the distance between the maximum and the minimum values is 4. So the amplitude A is equal to 1/2 of 4, or 4 divided by 2, which is equal to 2. Now to find B and C, we'll want to consider one period of our graph. Let's consider the period which starts here at -π/4 and ends here at 7π/4. The first thing we'll wish to do is consider the left endpoint. We know that in order to get the left endpoint of our period, we set bx minus c equal to 0. In this case, we know what the value of x is. It's -π/4, so we'll substitute that in, leaving us with b times -π/4 minus c equals 0. And we can use this equation to solve for c in terms of the other variable. If we add c to both sides of the equation, we have c is equal to -b times π/4. Now we'll consider the right endpoint of our period. Since the right endpoint of our period was 7π/4, we'll also consider b times 7π/4 minus c is equal to 2π. Since we already know that c is equal to -b times π divided by 4, we can substitute this in to our second equation, and we obtain b times 7π divided by 4 plus b times π/4 is equal to 2π. The left-hand side of this equation reduces down to b times 2π, and this is equal to 2π. We can solve for b by dividing each side by 2π, leaving us with b is equal to 1. And now that we have b solved for, we can substitute this back in for c, and we obtain c is equal to -π divided by 4. So now we found a, b, and c. So this graph is the graph of the equation f of x equals 2 sine of 1 times x, which is just x, minus a -π/4 or plus π/4. Thank you.